the HAWE Tech Podcast.
Welcome to our podcast. My name is Michael Knobloch. I'm the head of the key market management at HAWE. Today we want to dive deeper into the topic of seated valves. Seated valve technology is one of the core competences of HAWE. So today's question is then, what's the difference between a ball, a plate and a cone valve? Or are there differences? Diana is with us. She is the product manager for seated valves. Welcome, Diana.
Thank you, Michael. Thank you for having me here.
Before we start, I like to mention our white paper about seated valves. You find this white paper on our homepage. But now to the topic. Let's start with some basic facts. Seated valves is just a directional valve or to control the flow in one or the other direction, or is it more?
Yeah, actually, Michael, it's not just about that. It's more. When we talk about seated valves, we talk about the design principle. On the other hand, when we talk about directional valves, we talk about the functionality. The functionality is done with a certain design principle. We have already talked in a previous podcast about the main advantage of the seated valves. That is that they are leakage free. In comparison to the spool valves, that is another design principle. We also explained how we use the seated valves in a particular energy efficient way in the so-called on-off mode. So, however, that's for directional valves, but we can use it also for other functionalities. We use it, for example, also in pressure valves, we use it in check valves, and we use it in flow valves. For example, you can do safe clamping of a workpiece with a seated valve, or also the holding of a load pressure can be done with help of seated valve technology.
So today's question was to talk about the differences between ball, cone and plate valves. I think that it's not only one design for seated valves. Is that correct then?
Exactly. We basically distinguish between these three types. And each of these types has its advantages, but also, of course, certain limitations.
Then let's start with the ball valves.
Mm-hmm.
In my understanding, I just take a ball, like from a ball bearing, and all I need is then to manufacture a hole.
Yes, that's in principle, it's correct. And in fact, this is the most widely used design principle. There are a few essential things to be taken care of. One thing is the roundness of the bore. So this has to be very precise to get it leakage free. And the second is the quality of the ball. You can take it from a bearing, but there are different quality levels, and it has to be sufficiently good. The main advantage of the ball valves is the simple principle you described. This is a very robust design principle. It can withstand pressures up to 700 bars or even more, so very, very robust. And the limitation, however, is that the flow can only go in one direction. So this opens in one direction and the other one is closed, and that's it.
Okay, so can you name some product families?
Mm-hmm. Yes, as I said, it's used very widely. In HAWE, for example, we use it in directional seated valves when we have a very high pressure, like our G valves. Then we use it in pressure relief valves, like our type MV. In pressure control valves, you can use it, like CDK or CLK. And simply in check valves, where you want to open and close, like our RK and RB, and they are made of ball valves.
That's quite a lot. What about the cone valves?
Yeah, the cone valves have a major advantage. We saw the ball valves have only the flow in one direction. The cone valves don't have this limitation. Cone valves can be used with flow in both directions. It's also a seat. It also has to be manufactured very precise. And in this case, you have a cone and a bore. And only if they are made very, very precise and accurate, then it works still with the leakage-free way. And then you can use that advantage of bidirectional flow. We use it also in directional seated valves when we want to have this bidirectional flow, like in our Rolf valves, BVE, EM, EMP. They are made with cone valves. You could use it also in a check valve, like our pre-fill valve F, for example, is made as a cone valve.
So only design principle is left, the plate design. What can you tell about the plate designs?
Yes, the plate design is also a very, very simple design. Basically, you have also a hole that is covered by a lid, that is covered, by a plate that is like a lid, and this closes the direction. In this case, the platelet is very, very light, so you can use it for high frequency applications. It can open close very, very fast because it's so light, and you have also the possibility to use it as a restrictor check valve. When you drill a little hole into that plate, then you can use it, for example, in a forklift where you want to stop the load but then lower it very, very controlled. And usually we use it very often in our pump elements like PE and MPE that are very high frequency products, or also in restrictor check valves or check valves type RC and BC.
Okay, thank you. So I learned now it's not a valve one fits all, or not a design one fits all. Is that correct?
Yeah, exactly. So we have these different principles to cover all the different applications and all the different needs that there are out there in the world of hydraulic. If you want to have more information, if you want to have more details on that, you mentioned it, we have a white paper on seated valve technology. Check out. If there are any more questions coming up, just contact us at HAWE and we are happy to help.
Thank you very much, Diana. Just to summarize that, we talked about seated valve technologies, seated valve designs. We talked about the ball valves, very robust, high pressure application or suitable for high pressure application. We talked about the cone valves, suitable for bidirectional flow controls. And we talked about the plate design for very high dynamic application and or restrict track valves as the application for that. So thanks again for listening, and we hope that you don't miss our next podcast. If you have any questions, let us know at podcast@hawe.de.